Have you ever wondered how industrial motors are protected from voltage issues, phase loss, or imbalance? Today, we're going to break down this powerful device, the phase monitoring relay, and explain every knob and setting in a simple way. Let's take a closer look at this relay. This device is used to monitor three-phase power systems and protect equipment like motors, compressors, and pumps. If something goes wrong, like phase loss, voltage drop, or voltage imbalance, this relay will detect it and disconnect the system to prevent damage. This knob controls the unbalance percentage, range 2% to 10% or disable. It detects voltage differences between phases. Example, if one phase drops too much compared to others, the relay trips. Lower percent equals more sensitive and higher percent equals less sensitive. Important for protecting motors from overheating. In a three-phase system, all three voltages should be nearly equal. When one phase drops, let's say two phases are at 400 volts and one drops to 360 volts. You now have what's called a voltage imbalance. This imbalance might look small, but in reality, it has a huge effect on motors. The motor will try to compensate by drawing more current in the weaker phase. This causes overheating in the windings. Insulation starts to break down, and if not stopped, it can lead to complete motor failure. That's where the phase monitoring relay comes in. It constantly compares all three phases, and the moment the difference exceeds the set imbalance threshold, like 5% or 10%, it reacts instantly by cutting off the supply. So instead of letting the motor slowly destroy itself, the relay sacrifices operation to protect the equipment. This is the restart delay timer. Range 1 to 300 seconds. After a fault is cleared, this delay ensures system stability and no rapid on-off cycling. Example. Let's say you set this timer to 10 seconds. What really happens? When a fault occurs like a voltage drop, phase loss, or imbalance, the relay will immediately trip and disconnect the load to protect the equipment. Now, once the fault is cleared and the power supply returns to normal, the relay does not instantly reconnect. Instead, it starts counting the delay time you've set. Why is this important? Because in real electrical systems, faults are often unstable. For example, power might come back for 1 to 2 seconds, then drop again. Without a delay, the relay would switch on and off repeatedly. This rapid cycling can damage contactors, motors, and control circuits. The delay acts like a stabilization period. It ensures the power supply is truly stable. The system avoids unnecessary stress and equipment restarts safely. This knob sets the nominal voltage. Options of 208, 220, 230, 240, up to 480 volts. You must match this to your system voltage. Wrong setting equals incorrect protection. Imagine your system is running at 400 volts, a very common industrial voltage, and you set the nominal voltage to 400 volts, and your undervoltage knob is set to 90%. The relay will calculate as 90% of 400 volts equals 360 volts. So, if voltage stays above 360 volts, system runs normally. And if voltage drops below 360 volts, relay trips and protects the equipment. Now, here's what happens if you set the nominal voltage incorrectly. If you set it too high, let's say 480 volts while your system is actually running at 400 volts, the relay will think your voltage is always too low. So even when everything is normal, it will keep tripping again and again. On the other hand, if you set it too low, like 230 volts, the relay becomes less sensitive. It won't recognize real undervoltage conditions, and your equipment could be running under unsafe conditions without any protection. So whether it's too high or too low, a wrong setting either causes constant nuisance trips, or worse, no protection at all when you actually need it. This is the undervoltage delay timer. Range 0.1 to 20 seconds. It prevents nuisance tripping during short voltage dips and temporary fluctuations. Example, set 2 seconds, ignores very short drops. If you set the delay to 2 seconds, the relay won't react immediately when voltage drops. It will wait. So if the voltage dips briefly, say for half a second when a motor starts, the relay simply ignores it because the system recovers quickly. But if the voltage stays low for more than 2 seconds, that's when the relay steps in and trips. In short, it filters out short disturbances and only reacts to real problems. This sets the undervoltage threshold. Range 80% to 95% of nominal voltage. If voltage drops below this level, relay trips. Example, set to 85%, trips if voltage falls below 85%. This LED shows the status of the relay. On, normal operation. Off or blinking. Fault condition. Why is this device so important in industry? Without it, motors can burn out, equipment can fail, and production downtime increases. With it, protects expensive machinery, ensures stable operation, reduces maintenance cost, and improves system reliability. It's widely used in manufacturing plants, HVAC systems, pumps and compressors, and building management systems. If you found this helpful, don't forget to like, comment, and subscribe for more automation content. And let me know what device should I explain next.